Hi, everybody. Today we're going to be talking about Mac security features and how malware evades them. And just a little bit first about who I am. My name is Thomas Reed. I work for Malwarebytes. So a lot of the things that I'm going to be talking about today are things that I have seen firsthand. These malware techniques are all things that I've actually seen happening in the wild. They're not just speculation. With that said, let's go ahead and get started and look at first how macOS actually protects you. So there are a number of different foundations of macOS security. And as you can see here, there are quite a few. These all are essentially there to protect you against malware, either from infection or from the effects of malware, which could be things like data, theft of data, and that sort of thing. We'll go through each one of these one at a time and sort of explain what it is, why it's there, and then we won't get into the how to bypass it until we're done understanding all this stuff. So to start out, and these are sort of in chronological order, is the quarantine feature. This was introduced quite a while ago in macOS Leopard, or I guess back then it was called OS X Leopard, in 2007. And what this does is when you download something using an app like Safari or Mail or something like that, a quarantine flag gets applied to the file. And when you try to open that file that has the quarantine flag on it, quarantine will throw up a message just like this one that you can see on the screen, just to make sure that you understand that what you're opening is actually an application. The reason for this is that back at this time, there was a lot of malware going around that was pretending to be documents. So for example, what malware authors would do is they would copy a Microsoft Word document icon, and they would put that on their malware. So the malware would look like a Microsoft Word document, but it was actually an application. And this was pretty easy to do, and so Apple decided that it was best to just make sure that the user knew that they weren't opening a document in these cases. And all in all, I think this was a great feature to add. This particular feature actually cascades down to a bunch of the other security features. So it's involved in Gatekeeper checks, for example, XProtect, etc. So a lot of the stuff we're going to talk about is actually founded on this quarantine flag and whether it's present or not. So the next feature introduced was XProtect. This was in 2009 in Snow Leopard. Arguably the best version of OS X ever. And XProtect is a basic rule-based on-access antivirus program. So basically, when you double-click on an app that has been quarantined, XProtect will scan it and see if it's known to be a malicious file or not. If it is, XProtect will prevent you from opening it altogether. Your only option will be to either cancel or to move it to the trash. And this is also a really great feature. It's a basic rule-based thing. A lot of the rules are YARA rules, if you're familiar with that. So it's definitely got its limitations, but it's a really good first step here in protecting the user against malware. So a little later on in 2012, the MRT, which stands for Malware Removal Tool, was silently added to the system, and it was added in response to the flashback malware. Flashback was being spread at that time, and it was spreading through Java vulnerabilities. So that meant that the malware was getting into the system sort of through a back door and bypassing the whole quarantine system. So Apple had nothing in its toolbox at that time to protect against this kind of threat. So thus MRT was born, and it's a little bit of a black box. We don't really understand what's going on inside. But we have some ideas. We know that it scans periodically. We don't really understand exactly when, but it scans at a variety of different times, and it looks at your hard drive, and it removes any known malware from your hard drive. So this goes a little step beyond XProtect, which simply prevents you from opening. This actually goes through and proactively looks for malware and deletes it. So that's another really good utility. We don't really know exactly what it's looking for. We have some ideas by looking at strings inside the MRT application itself, but that analysis is it's tricky, and it's not always clear exactly what's going on. So shortly after MRT was Gatekeeper. This was introduced in Mountain Lion in 2012. MRT was not yet at a major OS release. It was in a patch release. So Gatekeeper was introduced, and it controls app execution based on code signing. Prior to this, code signing was an option, but it wasn't really a requirement. At this point, it kind of started to become an unwritten requirement. You know, you still to this day don't strictly have to sign your code, but it's really difficult for the user to run your code these days without a code signature. And as you can see here, Gatekeeper to this day will actually, at this point, you can't. It's very difficult to even bypass. Back in the day, you could set it to allow apps from an unidentified developer. These days, you wouldn't even see this particular dialog anymore. One additional thing that this can do is Apple has the power to revoke the certificates that these code signatures are based on. So Apple can very quickly kill a piece of malware and prevent it from spreading any further. Also, code signing is useful because if the app is modified, that breaks the code signature, and again, then macOS will refuse to open it if it has been tampered with. So this is all around a really, really great feature. It's very important to the security of your system. In 2015, in El Capitan, Apple introduced System Integrity Protection, or as most people just call it, SIP. And what this does is it prevents access to a number of system resources, even by the root user. So basically anything, just about anything in the root level system folder, for example, is completely off limits. Even if you have root access, you cannot make any changes there. At this point, it's gotten even tighter on Catalina because that stuff all resides on a read-only volume at this point. So SIP is really important. It's really good for protecting the system itself against modification by a malicious process or insertion of malicious processes into some of these system level directories. Then I say here that transparency, consent, and control was introduced in Mojave in 2018. Technically, that's not true. It has been there for a while. It's just that it wasn't very obvious. It wasn't particularly evident before Mojave. In Mojave, it started controlling access to a number of different things, mostly locations on the system. So if an application wanted access to, say, your Safari folder, or to your keychain, your contacts, stuff like that, that app would have to get the appropriate permission from the user in order to be able to access those resources. And TCC has been expanded further in Catalina to protect additional locations like the desktop downloads folder, which are locations where users may have potentially sensitive data. So this is not really a direct prevention of malware, but it sort of mitigates the threat of malware. So if you get infected, in theory, this should prevent malware from actually being able to get to your sensitive data. Now, it does have a little bit of a problem, as you can see. I'm sure that most people have seen many different dialogues like this requesting access. We'll talk a little bit more about that very shortly here. But overall, it's not a bad idea. I just don't like the constant harassment of dialogues, and users get tired of that. And then finally, introduced in Mojave, but really strengthened in Catalina, is notarization. So notarization is basically a process where you submit your software to Apple. They do some kind of an automated check on your software to make sure it doesn't contain any malicious processes. And once they're satisfied it's safe, they notarize it in their system, and they send you back some information that it's been notarized, at which point you can staple, I don't know why it's staple, but you can staple the notarization to your app, and at that point your app will run on Catalina just fine without any issues. Notarization wasn't really a requirement in Mojave. It was introduced there, but you could run an app that was not notarized without any problems. With one exception, in a point release, Apple did require that kernel extensions be notarized. But beyond that, you could run any app, whether it was notarized or not, without any problems. In Catalina, it became a requirement. So as you can see here with this example, not to pick on RingCentral specifically, there are a lot of apps that were not notarized when Catalina first appeared. But you can see here that by default, Catalina will not open an app that hasn't been notarized because it can't check it for malicious software. And there are ways to bypass that, of course, but it really does provide some kind of value, even though we don't know exactly what the process is at Apple. And I suspect that it's definitely possible to get malicious code through that review process. It does up the game a little bit, and it makes it easier for Apple to revoke a specific app. Revoke its notarization. So all that said, these are all really great features. I don't want to necessarily pick on any of them, except maybe TCC a little bit. But they all can potentially be bypassed. And so we're going to talk about some of the actual bypasses that we see in the wild for some of these things. So first of all, bypassing quarantine and by extension, XProtect, Gatekeeper, etc. A lot of these security features that are based on quarantine. What you can do, and what a lot of adware especially will do, is it uses an installer that kind of looks fairly innocent. It doesn't look particularly dangerous. It doesn't have any particularly nasty code in it. But also, that installer can very easily be changed without a whole lot of effort. So if Apple decides, oh, that looks suspicious, we're going to start detecting that, then it's pretty easy to change it. And then what that installer will do is it uses something like curl on the command line, or some other method that bypasses all this stuff, that doesn't set the quarantine flag. And it will do that to download the malicious payload. Another thing that can be done is if you've downloaded something and it has the quarantine flag on it, a malicious process can use the XATTR command to remove that quarantine attribute. What I find particularly amusing is we see a lot of adware and malware that uses curl to download a file and then uses XATTR to remove a non-existent quarantine attribute, since curl doesn't set quarantine. So that just sort of goes to show that some of these guys don't really know exactly what they're doing. They find these tricks probably on Stack Overflow or somewhere like that, and they just use them. They don't really necessarily understand them fully. But if you can do this, if you can bypass quarantine like this, then you have nothing to fear. Your malicious process, whether it's signed or not, whether it's known malicious or not, it will still run. Now, there is a slight exception to this on Catalina, where the first time you run a process that has not been quarantined, it will get checked. But it's still, this is still for the most part true. This can still work. So you can also bypass XProtect or MRT fairly easily. These both just use static rules. YARA in the case of XProtect, we're not exactly sure what MRT uses. You know, we can extract some strings from it, but that's about the extent of it. So really all you've got to do to bypass these, if you're a malware creator, is just change your malware a little bit. So here you can see on the right, there's an example rule from XProtect. This is a rule for something that we call vsearch. Other companies call it Pureit. Apple evidently calls it C592675. So as you can see here, really the detection keys on these three strings, and the file has to include 2 of those in order to be detected as malicious. So all you've got to do is change 2 of those strings and you're not detected anymore. And we actually have seen some variants of vsearch where they don't spell SH executor with an O. They spell it with an E instead. So clearly they're actively doing this sort of thing. They're actively changing malware to bypass these rules. You can also bypass code signing and notarization altogether. You know, these are great things because Apple can use them to revoke code signatures, kill malware, stop it in its tracks. And that's very, very powerful. When that happens, if Apple decides to revoke your signing certificate, your only option is to pay Apple another $99 on a different account to get a new signing certificate. And we've seen adware that has gone through dozens or hundreds of these certificates. So this is costing them money. And obviously, if you're a malware creator or an adware creator, you want to avoid that if at all possible. Especially as we're moving into Catalina and the restrictions are getting more and more intense. So why bother? Just don't bother signing and notarizing your apps at all. and you solve the problem. Now, admittedly, that makes it a little harder for the user to run your app. But as you can see from this image here, adware is already out there using techniques like this that allow that they show the user the exact steps that they need to do to run the installer, to run the malware. Basically, you just have to command click it or control click it, bring up the contextual menu and choose open, and it'll bypass all of this, even on Catalina. So this is something that we're seeing actively happening in the wild, and it makes it a lot harder because now Apple does not have a kill switch for this malware anymore. It's completely unsigned, completely unnotarized, but it's running on people's systems right now. Now, another method that you can use is to actually abuse an app on the system that doesn't have a quarantine flag. So I mentioned earlier that if one of the things that code signing does for you is it lets you determine whether an app has been modified or not. And if it has been modified, that breaks the code signature. And in theory, it should not be allowed to run. In reality, that really only happens the first time you run an app. So, the macOS will check an app's code signature the first time you run it. After that point, it doesn't check it again. Now, that sounds like kind of an egregious omission, but there is a reason for it. Certain apps can actually take quite some time to check. So if you're opening something like Xcode or Photoshop, if it had to check and verify the code signature every single time, you'd be waiting for about a minute or more for that app to open every single time you open it. So that's not really an optimal user experience. Unfortunately, that does also mean that there's an opportunity here for malware authors. And so I'm just going to play a little video here that shows we are on the latest version of Catalina. So notarization requirements and everything. And we're on the latest version of Chrome. Now, I didn't pick Chrome for any particular reason. It could be any app that is signed and notarized. And I'm going to run this infector shell script. You can see there's a TCC prompt there that is only used because of the way that script works. And now we open Chrome. And why did the calculator open? So you can see here on a fully up-to-date version of Catalina, this is 10.5 or 15.5.5. So this is the latest as of today. We can actually go in there and modify a signed and notarized app on the system and add malicious code to it. Now, in this case, the malicious code just opens calculator, but it could do any number of other malicious things to your system. So there's really no good way around this. I know that Apple is aware, and they are, I'm sure, considering some possible solutions to this. We at Malwarebytes are also looking into solutions, but that lengthy time for checking the code signature it can be a big problem for a solution here. So bypassing system integrity protection, to this I say don't bother. There's really no need. If I'm writing malware to infect your system, my malware can run and infect your system, grab your data, do all the bad things that malware wants to do without requiring even root permissions, much less injecting files into SIP protected locations. So here, you can see an old example here where, malware just put some launch agents into the user's launch agents folder. no special permissions needed there, and your malware is persistent on the system. So this is, SIP is good for what it's made for, which is protecting the system, but it really doesn't prevent your system from becoming infected in other ways. The one potentially big drawback to SIP is if users turn it off and then later turn it back on again, they can potentially get malware in the system that cannot be gotten rid of. And we've actually seen that fairly recently with a variant of a bird miner, which is a crypto miner. We saw one user who had a file in a SIP protected location. We still aren't really sure how it got there, but it prevented it from being removed. So no antivirus software out there would be able to remove that file once it's there. So if you are able to prevent this, prevent your users from turning SIP off. That could definitely cause you some problems. Bypassing TCC, as far as I know, there are no actual bypasses. No way that malware can automatically slip past. However, social engineering is a big thing here. I mentioned before all these TCC dialogues that pop up asking, do you want X to access Y? Do you want, A to access B? Just, constantly. So users get used to seeing those, and they just start getting used to allowing them. Especially, power users obviously are a different breed. They'll read each one of these dialogues to find out what's going on. But the average user doesn't care. They just want to get back to work. They just want whatever they're doing to work the way they're wanting it to. And so they're going to click allow every time. So all you've got to do is just socially engineer the user. Another possibility, but it requires SIP being turned off, is you could directly modify the tcc.db file. And this is an SQLite database that holds all of the data about what processes have been granted what permissions for TCC, and as well as things like which processes have asked for permission and been denied, because that's also important information. Once you've asked and been denied, you cannot ask again. The user has to go and manually give you permission. So that is it for this. There's really, as far as notarization is concerned, there's really no current bypass other than what we talked about bypassing code signing entirely. If anybody has any questions, I'm open.